Welcome students. Now I will demonstrate how to do the virtual lab. Today we are going to do the Newton's ring experiment. See, the first thing is there is an issue that you can think that this kind of experiments can only be done in your laptop or PC. But no, you can easily do these experiments using your mobile also. So for your information, I am doing this experiment using my mobile. The steps I am going to follow can be also followed using your laptop or PC. So all the procedures are same in mobile, PC or laptop. So let's begin. So see, we have shared a link with you. First of all, you have to go to that link. It will direct you to this kind of site. Then you click for simulation. See, here you get some basic questions what you have to answer. So let's answer. Which of the following is a planar convex lens? Newton's ring pattern consists of concentric rings. As we move away from the center, the rings become thinner and the rings get closer. What is the necessary condition for interference from the following? Okay, let's submit it. Then you have to select the medium for your experiment. You should select air. You have to just touch it. Then this window will open. You first touch on apparatus. There is a show button. You touch on show. So it will show you the apparatus. Then you touch on the light switch. It means you have switched on the light. Now see, there is your, you can see the lens. You can see the plane plate and the traveling microscope and the ring pattern. You just play with it. You can see there is a microscope control left and right. You click on right. You can see the microscope is going to the right side. You can click on left and you see the microscope going to the left. And here also in the ring pattern also you will get the change that you are going to right or left. Then you click on next. Here first the question is, what is the least count of the traveling microscope? Hope you all have done the Newton's ring experiment in our lab and you know the least count is 0.001. You submit it. Okay, see, it is saying it is correct. Now you click on show traveling microscope. Now you see, you are seeing the apparatus with the ring pattern. It is focused on the center of the ring. Here you see various options. One is microscope movement, one is lens movement, and here is the reading. See, if you click on the microscope movement left, so you see the microscope is going to the left side, and if you click on right, it will go on to the right side. There is a lens movement. You can go the lens up. It will give you a, you can see more rings at a time. If you move up the lens and down, it will adjust it accordingly. So what you have to do, it is the same procedure we are going to do as you have done in your lab. We will start measuring the diameters of the rings. We will measure the diameter of 20th, 16th, 12th, 8th, 4th ring. So first you have to go to the 20th ring. You set this left and count the rings and go directly, you go to the, slowly you can go to the 20th ring. Okay, I am not going to exactly a 20th ring. I am just demonstrating the thing. So when you go to this crosswire, go to your 20th ring, you will get some vernier scale reading and main scale reading. You note these readings by add to table. You see these readings has come in your table. So for this I will say you make a similar table as in your physics workbook in your copy and complete that table by getting the readings from this virtual lab. Means you will get the left hand reading of the 20th ring and put the vernier scale reading and the main scale reading in your copy. Then you go to the 16th ring, you get the vernier scale reading and the main scale reading of the left end of the 16th ring and put the readings in your copy. By this way, you complete your offline table in your copy. You measure this, the left hand reading of these rings and the right hand readings of the rings. Then you get the average, you subtract this and you will get the diameters. Then what you can calculate, it is already explained in your workbook. You follow the same things. You use the wavelength as 5893 Armstrong and calculate the radius of curvature. I think this is all, and this will help you to do the virtual lab. If you feel any doubt or any question, you can ask us directly via the WhatsApp group. We can ready to answer all the queries. Okay, goodbye students.